Hi doctor, my name is Ainin Fadlina binti Halim. My metric number is 233-03376.
Hi doctor, my name is Anna Sofia binti Safurizal and my metric number is 233-02688.
My name is Aina Farisha binti Rosli and my metric number is 233-03225.
And we will present our electronic project.
For this project, we built a combinational logic circuit on a breadboard. The breadboard is used to assemble and test the circuit without soldering. Logic gates such as AND, OR, and NOT gate are used to perform logical operations based on the inputs. Switches A and B act as an input, allowing us to apply logic high or logic low manually. LEDs are used as output indicators to show the logic results, where on represents high and off represents low. Resistors are connected to the LEDs to limit current and protect them from damage. Last but not least, jumper wires connected all the components on the breadboard, and a 5-volt DC power supply is used to power the circuit. So this is our truth table using the NOT gate, OR gate, and AND gate.
Hi, my name is Aina Farisha. I will explain how the logic gates are connected to form our circuit. For LED 1, the circuit is very simple. Input A and B are connected directly into an AND gate. The output of the AND gate is connected to LED 1. So LED 1 only lights up when both A and B are high. For LED 2, the circuit is more complex. First, input A goes into a NOT gate to produce A over bar. Then input A and B are connected to an OR gate to produce A plus B. Finally, the outputs A over bar and A plus B are connected into an AND gate to give LED 2. We built the same logic circuit in Tinkercad using logic gate components, switches for A and B, and LEDs for LED 1 and LED 2. This is our Tinkercad. Input switches A and B are connected directly into an AND gate, and the output of this AND gate is connected to LED 1 through a resistor. This ensures LED 1 turns on only when both A and B are high. For LED 2, the circuit follows the expression where input A is first connected to a NOT gate to produce A over bar. Then inputs A and B are connected to an OR gate to produce A plus B. Finally, the outputs of the NOT gate and the OR gate are connected into an AND gate, and this output is connected to LED 2. By toggling the switches in Tinkercad, we tested all 4 input combinations of A and B, and we observed that the LEDs turn on and off exactly according to the truth table.
Hi, my name is Ainin Fadlina and I will demonstrate the real circuit and show that it works correctly according to the truth table. And in this circuit, we use 2 input, which is switch A and also switch B. And the 2 output is LED 1 and also LED 2. When both switch A and B is 0, both LED will be turned off. When switch A is 0, switch B is 1, LED 1 will be turned off and LED 2 will be turned on. When switch B is 0, while switch A is 1, both LED will be turned off. When switch A is 1, switch B is 1, LED 1 will be turned on, while LED 2 will be turned off. What will happen to the output if any of the input pin is not connected? So a floating circuit on a breadboard occurs when one or more pins are not properly connected to a defined voltage, such as high or low. When this happens, the circuit does not have a stable reference voltage, causing the inputs to pick up electrical noise from the surrounding. As a result, the output becomes unstable and unpredictable, which may cause LEDs to flicker or logic gates to produce incorrect outputs. This makes the circuit unreliable and difficult to troubleshoot. And to overcome this problem, all input pins should be properly connected, and pull-up or pull-down resistors should be used to ensure stable operation. During the experiment, we've encountered few problems when conducting the breadboard, such as the output does not follow the truth table, and we overcome this by checking the gates used and the wires connection. Secondly, wires or components that do not make proper contact with the breadboard, and we overcome this by using solid core jumper wires. Thirdly, LED does not light up, and we check the LED polarity, which is the anode and also the cathode. And lastly, incorrect resistor value, which is it is too small for the LED, and we've overcome this by checking the resistor value with the multimeter.